Hey guys, I'm narrating over myself, so my eyes itchy, my sleeves don't work. We're looking at 9.1. I don't know why I'm talking like this, but the audio didn't work, so I have to redo it. We are going to learn about some significance tests. This is one of the two big things in statistics, is what I might be saying. All right, we're going to find p-values. You guys can read. You can always pause this and read it while I'm doing the secondary vocal thing. I probably just remade the video, but who knows. So now confidence intervals is one of the two common methods. Significance testing is the other one. This is going to allow us to weigh evidence for or against a claim. We're going to make some sort of hypothesis and either agree or disagree with it. All right, I want to pause this and see if we're. All right, I'm back. All right, look at me. So we're going to do something called a significance test, where we make our null hypothesis, and then we're going to see if it's right or not. We're going to reject it or fail to reject it. I'm sure what I'm saying here was great, but you guys can read and write and all that good stuff. All right, so what you're trying to find evidence against is called your null hypothesis. That's H sub O. And what you're trying to find evidence for is the alternative hypothesis. So you're trying to disprove the null hypothesis and prove, not prove per se, but say there's evidence for the alternative hypothesis. I'm probably saying it better here, but who knows? Could be saying it worse. I'm talking like an old gangster. Why do your eyes do that? So, for example, there's free throw shooter. Look at that form. It's amazing. And he says he makes 80% of his free throws, but we think he's a liar. So our null hypothesis is that the proportion is 80%. Our alternative is that we think it's less. So that's why it's our alternative. I'm going to use a highlighter now to show that same thing in which I just, but the highlighter's too small. You fool. This video is longer than what it needs to be. Alright. I hope people don't watch this. Except for my students. I hope they watch this. And read it. And love it. I should have just remade this video. I probably would have rushed it though. So again, null hypothesis is what we're trying to disprove. We don't think they're an 80% shooter. Alternative hypothesis is we think they're less than 80% shooter. What are you doing, Mr. Twiller? This is terrible. Alright, so if it's a one-sided test, it means we think we're either going to be less than, and there's two ones next to each other. Like that. Okay. Now, a one-sided test says that you believe you're either above or below your null hypothesis. You think it's either less than or greater than. A two-sided means you just aren't equal to your null hypothesis. So it can be above or below it. Okay? That's what those hand motions mean. Oh my gosh, I'm only a quarter of the way done. Ooh. And there's another, that's exactly what I was saying before. One-sided, it's either less than or greater than. Please, I know I'm not saying this much this time, but please really read through and bring in your questions tomorrow. I really do apologize that this happened. Again, two-sided means that it's just not equal to, so it could be above or below. Alright, please pause and read this question, guys. You have a pineapple factory. You guys can read it. But we want to know what is the null and the alternative hypothesis. So if you read it, you would have seen that they believe it was 31 ounces. So the null hypothesis, let's see if this guy in that sweatshirt does this. Here we go. So the null hypothesis is the mean is 31 ounces, is what I hope I write. Because then I'd be correct. Now the alternative hypothesis is going to be to see if the field changed. So it's that the mean is not 31 ounces. We didn't say it's less than, we didn't say it's greater than, we just said we think it changed. Yay, we did it. I'm proud. I'm proud. I'm just proud. All right. Now, you need to make this hypothesis before you see data. All right, guys. Don't be silly. And also make sure you use the correct parameters. Like, are you looking at the mean? You're looking at the proportion, and you're using the true. You're using parameter, okay? So the mean with mu. The hey, I did that with my hands here too, or the P without the hat. All right. All right. So this player says they're an 80% free throw shooter. They take 50 shots, and they make 64% of them. It's time to significant test this beast. All right, so when we look at the sample we ran, we did 400 sets of 50 free throws by chance. And 3 of them were at 6.4 or less than 0.64. So that means there's a 3 out of 400 chance of making 64% of your free throws on 50 shots given just straight chains. That's not very often. Dude's probably a liar. All right, so our p-value is the percent that made it, so the 0.03. So the p-value is evidence for the alternative hypothesis, okay? The stronger that is, based on our p-value, this one's 3 out of 400, so it's 0.0075. It's only 3 out of 400 of the samples actually had at or below what that player made. We'll learn how to do that later. Let's look at this problem. Stop and read it. So they say you should be getting 1,300. We're trying to disprove that. We believe the alternative hypothesis is it's less than it. We're going to do a sample of 20, and we got that the mean of the 20 was 1198. Standard deviation was 411. We found a p-value of 0.1404. So what would it mean for the null hypothesis to be true in this setting? Well, it'd mean that the daily intake of teenagers, calcium is 1,300 milligrams. Now, the p-value. This tells me that there's a 14% probability of getting a sample mean of 1198 in a sample of 20 teens. So that tells me that it's likely, it's plausible, okay? That's going to tell me that it's okay. Now, you guys can read. I'm sorry, I'm zoning out here. If it's unlikely to occur by chance alone, that means your null hypothesis is true. You have a small p-value, and you reject your null hypothesis. If it's not unlikely to occur by chance alone, when your null hypothesis is true, you have a large p-value, so you fail to reject. You can't accept it. You can't say, yeah, this is true, because there's still a shot it's not. But you can reject it and say, this probably is not true. All right? I'm probably saying a bunch to that. All right. So, if p-value is small, reject null hypothesis, and there's convincing evidence for the alternative hypothesis. If p-value is not small, we fail to reject null hypothesis and conclude there's not convincing evidence for your alternative hypothesis in context. Now, what's a good p-value? 5% is to go to. We can denote otherwise. That'll be our alpha, our A. But most time we're going to use 0.05 because 1 in 20 is pretty rare. Now, if they can tell you something differently, like 0.1 or 0.01. If they don't tell you anything, use 0.05 or 5%. All right. Again, that alpha is what you're looking for. They will denote it if they want something different. If your p-value is less than alpha, you reject. If your p-value is greater than alpha, you fail to reject. Read it. Read this. Statistically significant at that level, then. Oh, by the way, make sure you have your alpha done before you do your data. That'd be just goofy. Who knows what I'm saying here? You guys can make up your own words. Hi, my name is Mr. Twiller. I do math. Alright. B batteries. Alright, so you have a company making AAA batteries. They want to know if the batteries are good. The mean's greater than 30. They claim it is. You guys can read. You're going to do a simple random sample of 15 of the batteries. You're going to use them until they're drained. They found the mean was 33.93. They don't tell standard deviation, but we don't need it because we aren't finding P yet. So our null hypothesis is that the mean's 30. Alternative is that we think it's better than that. We think it's bigger. So we do the study. The p-value is 0.071. Can we conclude? Make any conclusions at the 0.05 level? We are not going to be able to. We're going to have to fail reject. I wonder what he's talking about in the upper right-hand corner. What you talking about, Mr. Twilliger? Here we go. Here we go. Answers. Answers are coming. Here we go. Here they come. Here they come. Here they come. So p-value is 0.0717. The alpha level is 0.05. Because our p-value is greater than our alpha level, we will fail to reject the null hypothesis. We do not have convincing evidence that the batteries last longer than 30 hours. Remember, never accept, always fail to reject, you crazy-eyed teacher up there. Here's some tips that you can read, because you know how to read, I hope, I think, maybe. AP exams coming for you. Who knows what it'll be? I'm here in my lab, looking at some stuff. Hey, type 1, type 2 errors. Sometimes we are wrong. A type 1 error is if we reject our null hypothesis, but the null hypothesis was true. Type 2 is we fail to reject our null hypothesis, we failed to reject it, but the alternative hypothesis was true. We need to know the difference between these and what can happen with it. We'll go over that more in class. Hope you guys enjoyed this. It was terrible. I apologize. Have a great day.